What if the most advanced telescope humanity has ever built just proved that everything we know about the universe is wrong? What if the light reaching Earth right now is coming from a place that, according to physics, should not exist? The James Webb Space Telescope was launched with one mission, to look back at the birth of the cosmos and confirm what scientists already believed. Instead, it has returned data so disturbing that entire teams of physicists are quietly admitting they no longer understand what they're looking at. A silence has fallen over parts of the astrophysics community, the kind of silence that only happens when something breaks a theory so completely that no one wants to be the first to say it out loud. So what exactly did James Webb find out there in the dark? And why are some of the most respected minds in science now whispering that the universe we think we live in might not be real at all? Stay with me, because by the end of this, you will never look at the night sky the same way again. It started with a single point of light buried deep inside one of Webb's earliest deep field images, a smudge so faint that most people would have scrolled right past it. But the astronomers who found it didn't scroll past. They stopped. They zoomed in. And what they saw made no sense. This wasn't a nearby galaxy. This wasn't even a galaxy from what we'd call the early universe. This was something ancient beyond ancient, a fully formed, massive, glowing structure dating back to less than 300 million years after the theoretical birth of everything. According to the Big Bang model at that point in cosmic history, there should have been nothing but a thin, cooling soup of hydrogen and helium, drifting quietly, waiting hundreds of millions of years before gravity could even begin clumping matter into stars. There should not have been galaxies. There should not have been light. And yet there it was, burning on Webb's sensors like a defiant flare in the darkness, daring anyone to explain it. Astronomers ran the models again. They checked the data twice. They checked it a third time. The galaxy was real, and it was not alone. Within months, Webb had located dozens more of these impossible objects, scattered across different fields of view in different directions of the sky, all sharing the same terrifying trait. They were too big, too bright, and too old to exist. Some of these galaxies appeared to already contain fully mature stellar populations, heavy elements, and structured disks, the kind of complexity you would expect from a galaxy that had been quietly evolving for billions of years, not one that supposedly formed in the blink of a cosmic eye. Astronomers have a name for the more compact, glowing versions of these objects now. They call them the little red dots, small, dense, impossibly luminous points that Webb keeps finding again and again in the deep field images, and no one can fully agree on what they are. Are they baby galaxies growing at an impossible speed? Are they overgrown black holes wrapped in dust pretending to be something else? Or are they something we don't even have a category for yet? Every explanation scientists propose only raises more questions than it answers. Here's where it gets even stranger. Some of these ancient galaxies aren't just massive, they are almost entirely made of stars, with barely any leftover gas or dust. In a normal galaxy, star formation is a slow, wasteful process. Only a small fraction of available matter, typically around 10%, actually collapses into stars, while the rest lingers as gas and dust for future generations of star birth. But Webb has now identified galaxies from the deep past that appear to have converted nearly all of their raw material into stars almost instantly, as if the natural, gradual process of galaxy formation was skipped entirely. Picture a factory that's supposed to take years to build a single car, suddenly producing an entire assembly line overnight, fully assembled, fully functional, with no visible construction process in between. That is what Webb is showing us, over and over, at the far edge of observable time. And once is an anomaly, dozens of times is a pattern. And a pattern this consistent means our understanding of how galaxies form may be fundamentally incomplete or fundamentally wrong. Which brings us to the question that's quietly terrifying cosmologists behind closed doors. What if we are not looking at the early universe forming according to the rules we know? What if we are looking at something else, wearing the mask of an early galaxy? Some researchers have begun to float the idea that what Webb is capturing may not be galaxies in formation at all, but relic structures, remnants bleeding through from a previous cosmic cycle, or from a region of existence that predates what we call the Big Bang. It's the kind of idea that sounds like science fiction until you remember it's coming from people with tenure at real universities, publishing in real journals, staking their reputations on numbers that refuse to add up no matter how many times they run the simulations. To understand exactly why this discovery is shaking the foundation of cosmology, we need to talk about something most people have never heard of: the Hubble sphere and the true boundary of what we call the observable universe. Space itself has been expanding since the beginning, and the further away an object is, the faster it appears to recede from us. Not because it's physically moving through space, but because space itself is stretching underneath it. At a certain distance, this recession speed actually exceeds the speed of light. Logically, we should never be able to see light from beyond that point, because nothing, not even light, can outrun that kind of expansion. And yet, thanks to the strange mechanics of an expanding universe, light from regions moving away from us faster than light itself can still eventually reach our telescopes, stretched, redshifted, and delayed, but present. Webb was built to catch exactly this kind of ancient, stretched light, coming from right at the theoretical edge of what we are capable of observing. But some of the signals it has picked up appear to originate from regions that shouldn't be visible to us at all under standard cosmological models, areas that lie beyond what should be our cosmic horizon, which raises an unsettling possibility. We may be detecting information from a part of the universe that formal physics says we are not supposed to have any causal connection to whatsoever. This single detail alone has been enough to send ripples of quiet panic through cosmology conferences. Because if Webb truly is picking up structures, or radiation patterns from beyond the theoretical horizon of causality, then our entire model of a single, contained, expanding universe with one unified beginning may need to be rebuilt from scratch. Some scientists have started asking the unthinkable question out loud, carefully, cautiously, but out loud nonetheless. What if the universe did not have a single, clean beginning the way we've always pictured it? What if the Big Bang wasn't the start of everything, but simply the most recent event in a much longer, much stranger story that we've only ever seen a fragment of? If galaxies can form faster than the standard timeline allows, if light can reach us from regions beyond our expected observable boundary, if massive, evolved structures are showing up where only cosmic dust should exist, then the entire foundation we've built modern physics on may be standing on far shakier ground than anyone has been willing to admit publicly. Now let's talk about something Webb detected that never made it into most headlines, because it isn't a stunning image, it's a signal, buried deep in background data that most people would never think to look at. While calibrating instruments, meant to filter out noise and background interference, researchers stumbled onto a faint, rhythmic pattern in the data, a subtle oscillation that didn't match any known source. It wasn't the steady, predictable pulse of a spinning neutron star. It wasn't the signature ripple of gravitational waves from colliding black holes. It wasn't cosmic microwave background fluctuation, the ancient afterglow radiation left over from the early universe that we've mapped extensively for decades. This was something else entirely, a repeating pattern at oddly precise intervals, subtle enough to hide inside the noise, but consistent enough that once researchers noticed it, they couldn't unsee it. Some have started referring to it informally as the heartbeat signal, a phrase that sounds dramatic until you actually look at the data yourself and realize how uncomfortably fitting it is, because a heartbeat implies something alive. And what's even more unsettling is that the pattern doesn't appear to be random. It follows a structured, almost mathematical rhythm, the kind of precision you'd expect from something engineered, not something naturally chaotic like most background cosmic noise tends to be. Nobody's officially calling this evidence of anything beyond natural phenomena, of course, because doing so publicly would be career suicide in most academic circles. But privately, in forums, in late-night conversations at conferences, in cautious footnotes buried deep in papers, researchers are asking questions they wouldn't have dared ask 5 years ago. What natural process would produce a signal this rhythmically consistent? What kind of exotic matter, if it even is matter, could generate a pattern like this? And why does it seem to intensify specifically in the regions of the sky, where Webb has also detected those impossible ancient galaxies? Correlation isn't causation, scientists will tell you, and they're right to be cautious. But when multiple anomalies keep clustering in the same regions of deep space, at some point, caution starts to look a lot like denial. Then there's the gravity problem, and this one might be the most mathematically terrifying of them all. Webb has observed multiple ancient, distant galaxies exhibiting powerful gravitational effects, bending light around them, distorting the appearance of everything behind them, influencing the motion of nearby structures in ways that clearly indicate enormous mass. The problem is, when astronomers calculate how much visible matter, stars, gas, dust, is actually present in these galaxies, the numbers don't come close to matching the gravitational influence being observed. This isn't a new problem in astrophysics. Dark matter was essentially invented decades ago to explain similar gaps between visible mass and observed gravity. But what Webb is finding pushes far beyond the normal dark matter discrepancy scientists have grown used to. Some of these gravitational anomalies are so extreme, so disconnected from any visible source, that researchers have started describing them as phantom mass fields, gravitational fingerprints pressing down on the fabric of space itself with no clear origin whatsoever. It's as if something invisible and unbelievably massive is interacting with our universe from just outside our ability to directly observe it, bending light, warping structures, influencing galaxies, while remaining completely undetectable to every instrument we currently have. Where could a gravitational influence like that possibly come from? This is where a theory, once dismissed as fringe science fiction, has quietly started creeping back into serious academic discussion. The idea of a parallel or mirrored universe existing alongside our own, invisible to direct observation, but capable of gravitational bleed-through under the right theoretical conditions. Some physicists, working on advanced models of cosmology, have proposed that if such a mirror universe exists, sharing the same underlying space-time fabric but operating with reversed or shifted physical properties, we might not be able to see it directly, but we could absolutely feel its gravitational effects rippling through our own reality. And here's the detail that makes this far more than just abstract theory. Webb has captured unusual asymmetries in particle behavior and rotational patterns within several of these distant anomalous galaxies, patterns that some researchers argue look like they're being influenced by a system running in reverse relative to our own, as though two separate cosmic frameworks are somehow overlapping at these extreme distances. If that interpretation holds any water at all, it means we may not simply be alone in an empty, singular universe. We may be gravitationally entangled with a mirrored, hidden reality, one that we cannot see, cannot measure directly, but one that is very much shaping the structure of the universe we live in. And then there's the discovery that even the researchers involved reportedly needed time to process before going public with it. One of Webb's long exposure observations was tracking the fading light signature from an object near the very edge of the observable universe, expecting it to gradually dim and disappear entirely, exactly the way distant light sources naturally fade over cosmic timescales. Instead, months later, the same spectral signature reappeared, not from the original direction and not on the expected timeline, but unmistakably matching the same unique light fingerprint as before. In astrophysics, spectral fingerprints are essentially unique identifiers, the exact combination of wavelengths and elements that make one light source distinguishable from another, similar to a chemical signature. For that exact signature to vanish and then reappear elsewhere is not supposed to happen under any standard model of how light travels through an expanding universe. There are only a few possible explanations, and none of them are comfortable. Either the light somehow traveled around some kind of closed, curved structure of the universe itself, implying space may be finite and looping back on itself in ways we've never confirmed, or that light encountered something at the very edge of observable space capable of reflecting it back toward us, something structured enough to bounce a signal, something that, according to every current model, should not be there at all. Layer all of these anomalies together, and you start to understand why quiet unease has replaced confident certainty in parts of the astrophysics community. The ancient galaxies that shouldn't exist yet, the little red dots that defy every model of formation, the rhythmic background signal that behaves like nothing natural we've cataloged before, the phantom gravitational fields bending light with no visible source, the eerie symmetry breaking that hints at a mirrored system operating in reverse, and now light itself appearing to echo back from the very edge of everything we can observe. Individually, any one of these might be dismissed as an instrument error, a data glitch, a statistical fluke waiting to be explained away by next year's peer-reviewed paper. But together, compounding, clustering, repeating across different regions of the sky and different observation periods, they start to paint a picture that no one in mainstream cosmology particularly wants to admit they're seeing. The picture of a universe that may not behave the way our equations say it should at scales and distances we are only just beginning to properly explore. James Webb was built with a simple, almost poetic mission, to look back through billions of years of cosmic history and help us finally understand our own origin story, to confirm the Big Bang, to map the birth of galaxies, to give humanity a clearer window into where we came from. Instead, it may have accidentally shown us something we were never fully prepared to see, that our understanding of the universe's beginning, its structure, and its boundaries might be dramatically incomplete, or in some fundamental way, simply incorrect. The impossible galaxies keep appearing. The phantom gravity keeps bending light with no visible cause. The strange rhythmic signal keeps repeating in the background data. The mirrored asymmetries keep showing up in distant rotational patterns. And that echo of light, bouncing back from somewhere near the edge of everything, still has no confirmed explanation. Every new observation chips away just a little more at the comfortable certainty scientists once had, the quiet confidence that we understood roughly where we are, roughly when we are, and roughly what kind of universe we're actually living in. Some of the most respected physicists working with this data have started admitting, carefully, cautiously, that what we're looking at might not be the universe we always assumed it was. And maybe that unsettling possibility is exactly the truth we were never supposed to be ready for. Maybe we are floating on the edge of something far older, far larger, and far stranger than anything our current models can explain. A structure behind the structure, a universe behind the universe. So the real question isn't just what James Webb found out there in the dark. The real question is whether the universe we think we understand is even the right one to begin with.